So these are the practice activities for Chapter 3. So it's lesson 1 through 5. This is how you prep for a test. I'm going to do through the odd ones, and then obviously the even ones, they're on you. So the first one says, write a phrase or mathematical expression and then classify them as numerical or algebraic. And the first one, I have 3, triple the difference between 12 and 9. So I put 3, and I have the difference between 12 and 9 means 12 minus 9. And that would be a numerical thing, right? And for number 3, the number of newspapers, N times the cost of each newspaper being C, that's going to be an algebraic expression. So let's look at number 5. Write each mathematical expression as a word phrase. Let X represent the number, right? This is going to be easy. It's the product of 9 and the opposite 2. That's easy, right? This one looks a little complicated to write about, but not really, right? You could say the difference of a number and 3 divided by 4. And if you want to get realistic, I put a comma. So you know that is part of the phrase. That's that part. And then you're dividing by 4. And number 9, that's really the simplest way, right? That is negative 7 divided by 7. Right? Okay. Or you could say the quotient of negative 7 and 7. There's 2 different ways you can do that one. Right? This is going to be a little confusing, I think, this part down here, right? And doesn't need to be. It's just sometimes that's what it is. I'm going to phrase this out. And I'm actually going to blow this up so we can take a better look at this guy, all right? Now, identify the terms in each expression, then name the numerical and literal coefficients of each term and the constant in each expression, right? So the first one, terms are separated by pluses and minuses. So in this case, 1, 2, 3, 4, there is actually 4 terms. Okay? I can put a semicolon, right? Name the numerical and literal coefficients of each one. Okay, so we have 8. These are coefficients, the numbers in front of the letters, right? So I have 8, minus 2, and 7. This is not a coefficient because it's just a number by itself, which makes it a constant, right? And we can say constant is 1, right? I'm abbreviating, but that's pretty straightforward. These two are going to work about in the same fashion. Simplify each expression by combining like terms. Now, you always got to remember the good old-fashioned PEMDAS for doing this, right? So make sure you remember this. So in this one, we're going to multiply across. This would be 3t times 4 is 12t plus t plus 8. Combined like terms, we should have 13t plus 8. Right? How about this one? PEMDAS, we'll get the multiply first. You can't combine these even though they're in the parentheses. Why? They're different terms. So you're going to make this 7n minus 33n and put this over minus 3n. N times an n makes that n squared. So 7n and 33n, that's going to make that what? 26n, right? So usually you put the highest n's first, and I say the ones with the most n's. So I'm going to write this minus 3n squared minus 26n, and that would be my answer, okay? So it doesn't really matter, but usually you put the one with the, so if this is n cubed, do you put that one in front? You just put the highest amount of n's in the front, usually, or variable, whatever you're going to have. So let's clear this. So slide down to number 17. Evaluate each expression if x equals 3 and y equals 7 and u equals 2. Well, that's easy. Just sub them in. So this would be 6 times 3 minus, what's this? 7 plus 2, right? Let's pull this thing up to here because I'm running out of space. This makes that 18 minus 9. So 9 would be my answer. I can circle it too. Say 19. I'm going to keep that. I'm going to go ahead and just do this one because it's independent. 9 minus my x, which is 3, divided by my u, which would be 2, right? So it's 6 divided by 2. Answer for that would be 3. Nice. Write it as an equation and tell whether the equation is conditional equation or identity. Okay? Conditional means, you're actually an algebraic equation. This is half a number, n. So n, half of that would be divided by 2, right? Is decreased by 3, right? Minus 3 equals 16. That's how you would write that out. And that would be definitely conditional. It's not an identity, right? There's identity ones where it's like you're trying to make it equal itself or you divide by itself. That's an identity problem. That's not an identity problem, right? Let's go down a little further. Let's take a look. All right. 23 is the sum of a number. Okay, this looks interesting, right? Sum of a number n plus 0 equals n. That's definitely an identity problem. Not a problem, an identity property, right? Because you're proving itself by just adding 0 to itself. That's an identity property. Let's do 25. Right? Determine the given value of the variable is a solution to the equation, right? Yes or no? So I'm going to put minus 6 in for the x, so it's minus 2 times minus 6 minus 4 equals 20. Well, minus 6 and minus 4 is like minus 10, right? So 2 times minus 10 equals 20. Well, negative times a negative is positive, so 20 equals 20. I would have to say, yes, indeed, that one works, right? Let's try this one. A equals minus 12, right? So I put 5 over 6 times minus 12 minus 3 equals minus 13. Looking at this, you can get rid of this 6 very easily by changing that to a 2, right? Just divide this out. You get rid of that. So then you end up with 5 times minus 2, right? Minus 3 equals minus 13. So 5 times minus 2 is minus 10. Minus 3 equals minus 13. So, yeah, minus 13 equals minus 13. So I can put a yes for that one. Right? So it's making sense. Scrolling on down. Now, these I'm going to take a little thinking. Now, I'm going to show you where this is, okay, and then you can follow me. So if you go back to our page, okay, and it says work problems, I'm going to open this link in a new tab, right? Boom, okay. So if I go here, we have something here that's important for doing this. It says the properties of equality equations. We're going to use this to solve our problem, okay? So this is a nice review of this. Reflexive, which means you have the same thing on both sides. Symmetry is A equals B, then B equals A, right? Transitive, A equals B and B equals C, then A is equal to C. It's just like, it's a logic problem right there. Addition, you add something on one side, you can add it to the other. Subtraction, subtract something from one side, you can subtract it from the other. Multiplication, same concept. You multiply one side, multiply the other. Division, divide by one, divide by the other, right? Pardon me. So this is what's being looked at in this next section, all right? So I have 12 divided by V equals 4. Then I have 4 equals 12 divided by V. So what has happened in here? Well, you kind of flipped it, right? So looking at what's going on here, it's symmetry. A equals B, then B equals A, right? Think about that. 12 minus V equals 4, then 4 equals 12 minus V. So that's definitely the symmetry, right? I'm not going to write it all the way. I'm just going to say SYM. Let's do 31. E minus 6 equals 14, then E equals 20. Well, what occurred here? Well, we added 6 to this and added 6 to this. So it must be additive, right? The additional property. We just added 6. It's implied. You're not seeing it. So you're going to put down add, right? So I'm just going to write down add, ADD. Okay. Let's take a look at this next one. It says, if R plus 1 equals 5 and 5 equals 13 minus S, then R plus 1 equals 13 minus S, right? R plus 1 equals 5. So let's make this A. We'll make this B. And we're saying, well, let's make it B so you can read it. And say B is equal to C. Then we can see where this is A is equal to C. What does that fit? Well, if we look at that one, it has to be the transitive. A equals B and B equals C, then A equals C. So that's a transitive one. Okay? So everyone see how these things work? And obviously these you're going to figure out on your own. Right? Let's take this. Let's roll down a little bit. It says solve. You've been doing so many of these. Okay? I'm going to try these out. And I'm going to do, obviously, I think I'm not going to do all of the odds here. I think I'm going to cherry pick. I'm going to do, I'll do this one, right? The decimal is the same thing as using a calculator. So I'm going to grab one that does this. Okay. And I'll do this one. The rest of them, you guys have been doing so many of these worksheets. You should be able to do these without a problem, without a hitch. We'll find out. Let's take this one. T plus 14 equals minus 9. You're going to be subtracting 14 from this end to get the variable by itself, right? And then when you add this together, what do you get? T equals minus 23. Okay? Because these guys are going to cross out. Now, how many of you done like this? I mean, really, we've done so many worksheets. You're probably like, oh my gosh, I can't stand this anymore. So we have somebody have fractions, right? So you can move the fraction to the other side, okay? And you should know how to do that. Now, mixed fractions are not bad, right? You can do one or two things. You can make this one. I didn't circle 39, but I'll do it anyways. Why not? Let's do it. So I can make this 3 and what? 2/4 to make it easy on myself, right? I just changed it to something I can use for both ends. Or you can plug in your calculator if you wanted to, right? But if I did this at negative, I have to add it. 3 and 2/4 plus 3 and 2/4. So F is going to be equal to what? 1, 1, right? 2 plus 3 is 5/4. So you're going to end up with, anytime you have 5/4, you're going to make it just 1/4. And take one of the ones and add on here, so 3, 4, 5. So it's 5 1/4. Okay? Should not be too taxing. Hopefully you've seen something like this along the way. These are the ones a little more confusing. If you take this, you got to divide both sides by 15. And your answer at S will be equal to 7. We'll do this last one. 6R minus 36R equals 168. So you got to combine like terms. This makes this minus 30R equals 168. Okay. Divide both by negative 30. Negative 30. Okay. Your R in this case would be equal to, if you do a calculator, it'd be negative 5.6. That's the minus. Okay. And obviously, using a calculator is going to make this easy. You can use a calculator in this course. So, all right. See what's going on there. And here we go. Let's keep plowing down. Word problems. Everybody loves a word problem. The problem with word problems is that they're word problems. I'm just kidding you. It's easier to write the numbers on top as you do it, right? 2 less than 3/5 of the students play sport. So I write, this is how I keep these things straight in my head. I write 3/5 minus 2 based on this. But we don't know 3/5 of the students, so this actually is wrong. So what you would really want to write is 3/5 times the total number of students. We don't know, we're just going to make it n, right? So I'm going to write 3/5 of n minus 2. 3/5 of the students. Or I can make it s. 3/5 of s. S is the total number of students, right? That's what we do it. 3/5 of s minus 2. If there are s students, well, look, I just did it the way they want it, right? How many like to play sports? Write your answers in algebraic expression. Then find the number of students selected by choice if there are 225 students. Ah, nice. Okay, so I rewrote my equation, right? 3/5 S minus 2, right? And then I'm going to sub in 225. So 3/5 times 225 minus 2, okay? And if you did your math right, okay, which is not hard, you should get the number 133 students, all right? Let's look at this one. Lou, do not know Lou, hung a total of 240 photographs in equal rows on a wall. In each row, he hung 17 photographs. How many rows did he create? Write and solve an equation. So we know he hold a total of 204, so we know the n would be 204. You could put down either way. I'm going to do it like this. Each row, he hung 17 photographs. I know I have 17 photographs he's hanging, but I do not know the number of rows, right? Should be fairly easy. So you just divide, obviously, by 17, divide by 17, R equals 12. I guess I've got to circle this one over here too. So that's it. That's for the first part of this lesson thing. Hopefully you found this very, very useful.